Good morning, good afternoon, and good evening, everyone, wherever in the world you may be joining us from today. My name is Francesco Del Carpio, and I am the CFL York Operations Coordinator. I would like to officially open the fourth session in our Mind Action, Innovation, Sustainability, and Global Partnership Speaker Series, presented in partnership with the Advanced Disaster and Emergency Rapid Response Simulation Lab, Subsphere Corporation, and AVO Tracks. I would like to begin today with a land acknowledgement. First Nations peoples have lived on this part of Turtle Island for millennia, stewarding the land, the water, and all that contributes to life in this region. Today, the culture and presence of First Nations, Inuit, and Métis peoples enrich the lands and people of this territory. More than 2 centuries ago, the Mississauga people welcomed settlers to this territory, providing sustenance and engaging in trade and commerce. Between 1781 and 1820, 8 treaties were signed with the Mississaugas of the Credit First Nation, who opened their territory to settlement. Today, York University's Keele campus is located on Toronto Purchase Treaty Number 13 lands and is situated on the traditional territory of the Huron-Wendat and Haudenosaunee. Treaty history is foundational, and it is our collective responsibility to honor the land as we honor and respect those who have gone before us, those who are here, and those who have yet to come. We are grateful for the opportunity to be learning, working, and thriving on this land, and we commit to learn the truth and be active in the process of reconciliation. As this is an online event, our participants may be joining from various locations, so I strongly encourage you to learn about the traditional land upon which you are located. With this, I welcome our moderator, our speaker, and our participants from around the world. Welcome to our webinar. It is now my great pleasure to introduce our moderator today, Michel Arif. Michel Arif is an R&D coordinator at Subsphere Corporation with a strong track record in project management and the strategic application of emerging technologies for disaster risk reduction. She holds a master's degree in disaster and emergency management and has a robust background in applied geospatial technologies and climate science. Michel, thank you very much for moderating today's session and your ongoing help in putting this series together. The floor is yours.
Thank you, Francesco. Thanks for that warm introduction, and welcome to everyone. Thank you for joining us on our fourth session of our Mind Action webinar series. This is where we talk about innovation, sustainability, and global partnerships, all kind of surrounding Mind Action. I've had the privilege of meeting today's speaker, Dr. Robert Keeley, who I'm thrilled to introduce and have him walk you through what it really takes to dispose of explosive ordnances in the field and speak to his many years of experience in both academic and field experience. Dr. Robert Keeley is a former British Army bomb disposal officer who is active in humanitarian and commercial mine action and explosive ordnance disposal since 1991. So lots and lots of years of experience. He has worked in numerous countries for several governments and international organizations. He specializes in project design, evaluation, and quality assurance of all aspects of mine action, EOD, and has helped to shape the emerging humanitarian improvised explosive device, the IED sector. Dr. Keeley is a member of the Institute of Explosive Engineer, a member of the International Association of Bomb Technicians and Investigators, and is a fellow of the Royal Geographical Society. So that's a lot there. This is going to be a really interesting chat. But before we begin, just a quick note, the chat box is open. Thank you to everyone that's typing in there where they're joining from. Feel free to chat there, but we also have our Q&A box. So that's for questions specific to Dr. Keeley. Feel free to pop those in at any time. While he does his presentation, he's open to discussion and questions. So he has a green slide in his presentation to kind of separate the sections. Whenever that comes up, we'll take a little pause. If there are any questions, we'll address those there. And we look forward to his presentation. So with that, Dr. Keeley, the floor is yours.
Good afternoon or good morning, depending where you are. Francesco, is my screen, is it working?
Yep, it looks great. Thank you.
Okay, well, with no further ado, hello everybody. Some of you will know me. I notice in the chat already that some of the old and bold from the mine action sector have joined us. You won't learn very much from me because you guys have been around, some of you as long as I have. But feel free to chip in. This is really aimed at those innovators and those potential innovators out there. So this is about putting context on the sector for those people who are doing their best to make our lives better, for which I'm very grateful. So let's press on. So there'll be an introduction. We'll talk about what we call the mine action pillars and the products, which are not quite the same thing. We'll talk about what we need from you, and that is faster, cheaper, or safer. We'll talk about mine action as a system. We'll talk a bit about risk and liability, and then we'll finish up with some ideas for test protocols. So here's one of the green screens that Michelle talked about. Whenever you see a green screen like this, it marks a gap between the different sections. And I'm very happy to take questions at each of these stages so we can break the thing up a bit. But let's carry on for now. An overview. Right, well, what is mine action? Our source for many of the things that we do is International Mine Action Standards, or IMAS. And it tells us that mine action consists of activities which aim to reduce the social, economic, and environmental impact of explosive ordnance. So I want to pause just there for a second, because sometimes we confuse mine action with mine clearance. Mine clearance is only one of the things that we do inside mine action. So please bear that in mind. Another quote to reinforce that from IMAS is that mine action is not just about demining, it's also about people and societies. So let's bear that in mind. What are our objectives then? Well, our objectives, first of all, is to reduce the risk from explosive ordnance to a level where people can live safely. We want to allow economic and social and health development, and we need to address the needs of the victims of the explosive ordnance. So the aim today is to introduce the mine action sector, introduce what we need from you, from your technology. And let's start there with some terminology. You'll hear these phrases bandied about, and it's useful just to get this down. So at the top of the hierarchy, we have explosive ordnance, anything that goes bang. Underneath that, we have explosive remnants of war, or ERW, and we have landmines. Now, these are slightly different categories because, and again, we have these other things here, abandoned explosive ordnance and unexploded ordnance. And the key matter is that these are accidental. These are left behind as a consequence of things that were supposed to go bang but didn't. But these things over here are deliberate. They were left deliberately for the victim, be that an anti-personnel mine or an anti-tank mine. The mines are unique because they are devices activated by the victim. We are, I'm afraid, full of loads of terminology and jargon like this. So you have to get aboard it really, because that's what's out there. Now, the aim is, frankly, and Francesco did offer me a chance to be very careful about what I say, but our aim is to stop you building stuff like this. I won't go into too many details, but this particular device got a lot of publicity and a lot of money, and it's totally useless. This was supposed to be blown by the wind across the minefield. Well, I won't say any more, but please don't build us stuff like this. We can't use it. So here's the first of our green screens. Any questions about the introduction so far?
I don't see any questions so far, but thank you for that terminology. I think if anyone wants to take notes, this is a good presentation to also take notes in.
Okay, then let's carry on. Mine action pillars and products. So the pillars. Since 97 and the first of the big conferences, the Ottawa Conference about anti-personnel mines, mine action has been described as having 5 pillars. That's clearance, explosive ordnance risk education, which is something that's gone through different name changes, but you know, the clue's in the name. Victim assistance, advocacy, and stockpile destruction. Those are the 5 pillars of mine action. But those are not the same as our products. Now, what do I mean by that? Well, first of all, there's some really useful infographics or some icons that the UN has developed. So there's our clearance pillar. There's the risk education. There's victim assistance. There's advocacy, and there's stockpile destruction. They're great little icons, and I use them all the time. But products are something not quite the same. A product in business is a thing that can be produced. It has results or impacts. And what does that mean to us as mine action practitioners? Well, it means a reduction in casualties caused by explosive ordnance. It means an increase in the use of productive land, and it means survivors being reintegrated into society. Because the wounds that they get from ordnance are genuinely life-changing. So it's not something that you just walk away from normally. So let's stop and think just for a second about which of those pillars ties up with the aims of mine action and with the products I talked about. The reason this is useful, I hope, is that as you sit there as innovators with brains the size of a planet, is that you'll think about ways that you can help us achieve these things. So remember our aims in no particular order: survivors reintegrated into society, an increase in the use of productive land, not just the productive land itself, and a reduction in casualties. So victim assistance is a pillar and a product because it helps when it's targeted properly with the first one. Clearance helps, but does not in itself. It is necessary, but not sufficient in gaining the use of productive land. And a reduction in casualties can be done by a combination of risk education, of clearance, and of explosive ordnance disposal, which is a technique and a type of work which is implied in the term clearance, but actually it's a very different animal. So there are other activities that we do. We do various kinds of survey, but they don't produce an outcome themselves. Nobody in any mine-contaminated village anywhere in the world has ever directly benefited from a survey. The survey may help us do our job, but it doesn't directly benefit the benefit, the population. So they can't be considered as products. They're enabling activities. They're useful, and particularly for clearance. They enable us to do our job, but they are not a product in themselves. So, any questions so far?
Looks like you're doing a really good job of clearing up any terminology and
Well,
factors. So, no question.
either that, Michelle, or I'll put them all to sleep. Let's press on. So, the next section: faster, cheaper, and safer. This is my dad. For those of you who can recognise his cap badge and can see his shoulder flash, he was also a Royal Engineer. And if he was alive today, he would be able to recognise more or less the procedures that we still use. So in the 80 years since his day, in many respects, the way that we clear mines hasn't really changed that very much. There was a conference called URL and sponsored by the Institute of Electrical Engineers in 1996, and I was very lucky. I was able to present at that conference, and the conference was called "The Detection of Abandoned Landmines: A Humanitarian Imperative Seeking a Technical Solution." I was lucky to present. I was probably the least intelligent person in the room. Lots of scientists there, all very eager to use their skills and their knowledge to improve what we do. And here's what we do. This is an old photograph from the late 90s of a deminer in Cambodia. And one thing I'd ask you to bear in mind is that in this, we already have a solution. we haven't spent the last 30 years standing by the edge of a minefield, scratching our head, wondering what to do in a minefield. We've got a solution. Here he is. He earns a couple of dollars, $100 a month. He can be a man, he can be a woman, he can be a mine casualty himself, and he does the job. So that's why we need something. If it's going to make a difference to us, it's got to make his job faster, it's got to make it cheaper, or it's got to make it safer. Make our work faster, make it cheaper, and no less safe than we already are. Now, many of you from coming in from the outside think our job is desperately dangerous. Actually, it's not that dangerous compared, and I'll show what I mean. There was a study done by the GICHD, the Geneva International Centre for Humanitarian Demining, on manual mine clearance. I was part of the study, but the bit I'm going to talk about now is the risk. In 2005, and it included this sub-study on risk. And I'll leave this graph up here for a minute, because the risk section of this study looked at the risk to deminers as a profession compared to workers in other industries. And you can see here the risk specialist who did this section. He looked at building, he looked at forestry, and he looked at an insurance agent for some reason. And risk is measured in exposure hours, and from the data that was available, and he was using Afghanistan data. And for those of you who don't know, Afghanistan historically has always seemed to be the country where the deminers have the most accidents. Bear that in mind, because the deminer, as you can see, his work, my work, perhaps in the past, but my work when I was doing this work myself, and deminers who are working today, it's actually not that risky as an occupation. So we need you to, I mean, we're absolutely happy if you can make it safer, but it needs to be no less safe than what we currently are. Now, let's move that on a bit and talk about Warwick University. Now, they're worth mentioning because this is a success story for innovators. They visited Bosnia and Croatia in 1995, and I was working there, and they made two key observations. PPE, our protective equipment, was heavier than it needed to be, and vegetation was a problem for us. Here's an arm that we were using military style PPE, military helmets, flak jackets, for want of a better term, with armored backs. Sorry, I'll go back a bit there. And Warwick University pointed out that we didn't need necessarily to have these big heavy helmets, and we didn't need to have these big heavy panels on the back of our protective equipment. And they also pointed out that we were spending, we had a problem with vegetation. We were cutting a lot of vegetation as we were going through our work. Here's an example of the protective equipment they started making. You can see it's just a visor and an apron. And they also built this machine called the Tempest, which was a very low cost, low weight, low impact device aimed at brush cutting. Now, what's interesting is that ever since then, their equipment, here's an example of somebody using that type of visor and that type of apron. So Warwick University really set the scene, and essentially every piece of PPE that we've used since is basically modeled on Warwick University's findings. And there's another machine, not one of theirs, but a small remote controlled machine, which again is the benchmark now for how we do our work. So Warwick University were particularly successful as a bunch of academics who came over, saw what we were doing, and made a difference. Well, how did they succeed? First of all, and I can't stress this enough, they visited the ground. They talked to people, me, loads of other people, deminers themselves, but it almost failed. And it failed because we had a lack of common language. Now, not because of English, we all spoke English, although they had a strange northern accent. Um, but there was confusion over the word problem. As far as I was concerned, as a former soldier, we didn't have a problem cutting vegetation. We had a drill for it. We knew how to cut it. We got on with it. For me, as a former soldier, a problem was something that we didn't know how to solve. What Warwick pointed out remarkably well was that we were spending 75% of our time cutting grass. It wasn't a problem that we didn't know how to do it, it's that we were spending most of our time gardening. And that was an eye opener for me, and it's been an eye opener for Mine Action ever since. So they were successful, but why do people fail? Why do innovators fail? Why does Mine Action still basically look like something that my dad would recognize? Well, there's two main reasons, I think. And it'll be interesting to hear, comments from the old and bold in the audience. But I think there's two reasons why innovations fail. There's a failure to situate. They don't visit the ground. They don't understand our systems or problems. And they don't talk to us early enough or can't interpret what we say. And then there's a failure to demonstrate. They don't prove to us that their equipment solves what we need. And part of that is because at the moment there is no system for benchmark testing. Remember, faster, cheaper, or safer. If you take nothing away from this, else away from this presentation, please remember those three words. We end up either with ideas which are cheap but not effective, like this thing, or things like this, which are potentially technically effective, but enormously heavy and enormously expensive. And it pains me as somebody who became an economist myself that we never consider cost and cost effectiveness in the equations for any of this stuff. I trialed one piece of equipment in Afghanistan 20 years ago, and it was technically very effective, but it used so much diesel per hour that it was going to be more expensive than the deminers it was going to replace. So cost effectiveness is really important, and it's the bit that we all seem to ignore. So another green screen. Any questions so far?
Yes, we do have questions. We've got two. The first one pertains to, the first one pertains to the graph that you were showing us about
Yes.
incidents. So just if everyone remembers that. So Pedro Basto is also here. He's the program manager and research for innovation at GICHD. He posted a link in the chat box about some more information of accidents and incidents in the demining sector. So if anyone's interested in doing another deep dive into that, that's a really good resource. And then a question popped up about defining incidents. So how do you define an incident?
Well, that's really good. I'll take the last question first.
Yeah.
The IMAS has a 20-page questionnaire which medical people are supposed to fill in on a casualty. Frankly, it's useless. A doctor may need to use it, but it's no good to us. From an epidemiological point of view, there's a much simpler system that was invented by the ICRC by a surgeon who was working in Afghanistan in the early 90s. And it divides typical mine casualties into three patterns: pattern 1, pattern 2, and pattern 3. Pattern 1 is traumatic amputation of one or both legs, and the useful thing about it from an epidemiological point of view is that's associated with stepping on a mine. Pattern 2 is multiple lacerations or wounds, and again, from an epidemiological point of view, that's associated with standing near something when it detonates. That could be just watching somebody else clear something or do something or tamper with an item. And then pattern 3 is traumatic amputation of one or both hands, wounds to the face, wounds to the eyes, and that again is associated with handling an item. And those three patterns, because of their epidemiological significance, are really, really useful. And it's unfortunate that our sector doesn't use them very much because they're very powerful. But if somebody wants to contact me later, I can always give them the connection to. There was Dr. Robin Copeland who wrote up about these in 1993, and I can find you the link to his paper. I didn't invent it myself. I just think it's a great system. The demining incident database that Pedro has referred to was actually developed independently by a man called Andy Smith, and then it was given to the Geneva Centre to pick up. It's got a problem. It's a great idea, but it's got a problem, and the problem is that contribution to it is voluntary. And so Andy found himself, and he hoped that the Geneva Centre would be able to do it better, but it relies on people to contribute, and a lot of organisations don't. You know who you are because some of you are listening, but some of you don't contribute to this. And so we have a dark figure, as statisticians would call it, of data that isn't contributed to that. And it only measures deminer incidents. There are a couple of databases out there for casualty databases in general. There's one in Cambodia called Simvis. There was one in Laos for a time. The problem is it's not universalized, and they sort of exist to a greater or lesser extent, but it's not standardized in other countries. We could do with more of that data.
Oh, that's
Okay.
fantastic. Yeah. Shortfalls are very important to note for sure. So still a good resource, but be mindful of that shortfall. The second question that we have, it's a bit of a long one, but it's from Quentin Innes. Quentin says that they're working with a robotics company, and one of their concepts is to leverage swarming. So the idea is clearing a system consisting of a mothership containing expensive bits working with a swarm of less complex robots, then detect and mark on the first pass, and then pick up on the second pass. So the team would be supervised by a human. That way, if one of the swarm robots gets detonated, the team does not lose the expensive robot, and the rest of the swarm can close the gap and carry on. What are your thoughts on this?
Absolutely no thoughts whatsoever, because if I share a thought now, it'd be prejudicial. My questions are, have you situated it? Have you demonstrated it? And are you going to make it faster, cheaper, or safer? And so let's get to the rest of the presentation. I'd be happy to talk to him offline about it. But I don't think it's appropriate for people just to list opinions about stuff without even seeing it. If you remember, there is something called a hierarchy of evidence, and it goes at the top from meta studies and randomized control studies, and it worked its way down, and right at the bottom is expert opinion. So I don't think my opinion on what I've just heard in 30 seconds is really worth that much.
Right, yeah. Feel free to contact Dr. Keeley after this presentation for other thoughts. The third
Absolutely.
question comes in from David. He's asking, does a vegetation cutter from Warwick University trigger the mines that they're going over, if they do go over them?
Sometimes, yes, it did. And sometimes that's not a bad thing. It will, machines like that will, they'll get rid of anything operated by a tripwire, and they will, anything that goes under the wheels or the tool itself may well be triggered. And versions of that, it's based on a much bigger machine that was developed in the Second World War, that was designed specifically to make mines explode. The problem is those machines aren't 100% effective for a bunch of reasons. Which means that generally we would like to see a manual deminer follow them up. But they do remove some of the hazard, but they're not 100% effective.
Perfect. Those are all our questions. Thank you so much.
No, my pleasure. Okay, now let's talk about mine action as a system. This is a picture from Kuwait in 1991, and we thought, as mine action people, as deminers, that our job started at the minefield fence. And you can see, if you look very carefully, some of the minefield fence that's here. Actually, we came to realize afterwards, and essentially the subject of my PhD, was that by the time we get to here, several big decisions had already been made. So in many respects, the hard decisions are made before we get to the minefield fence. And in fact, here is my PhD thesis. It's a one page. It was just supported by 400 pages of explanatory notes. But the point being is that these 8 resource allocation decisions have to be made before we get around to actually doing clearance. And as you look, if you look at number 7 in the bottom center, choosing technology is only one of these resource allocation questions. Which country are we supporting as a donor? What type of program do we support? And so on. All those big questions make a much bigger difference to a program, and all have to be done before we start clearing ground. You will have heard the phrase, I'm sure, of land release, and there's copious stuff written about it. But it basically follows a series of steps. A risk assessment, something called a non-technical survey, which is essentially, it's something that's existed in the development world for decades, but we've borrowed it. The development world call it a participatory rural appraisal. We've given it another name, but it's basically a social science survey of people's understanding of their problem. There's that, followed by a technical survey to find out the technical nature of the contamination, and that's followed by full clearance. The reason this is important to understand this is because the value of that to the affected population actually increases as you go up the pipe. Deciding whether your government is going to support a country or not in its mine action program is a very quick decision to make, but it's worth millions of dollars. Whereas clearing 1 square meter of land produces, a few cents of crops. So the value of those steps in land use actually increases as we go up the list, but its cost increases as we go down the list because cost clearance is expensive. Here's an example of how some of this was done. This is a map from the fighting in the what was then the former Yugoslavia, and we used this type of data, what we would now these days call a heat map, to work out, for example, that this province, Istria, in the west of Croatia, was never affected by the war, so there would be no need to ever go and do any mine action there. This is a similar map I did in Ukraine a couple of years ago. It's out of date now because these things they're a living document, but the point being is that we could assess the likely hazard in an area depending on the heat map of essentially where the fighting had been and where it currently was. Which brings us to this. Mine action is a system. In the middle there, in the black box, we have the at-risk population. And remember, this is all about people. And there is a connection between the at-risk population and casualty numbers. And the red boxes are the things that affect those people. There's 3 axes. There's economic pressure to use the land. There's the population's attitude to risk. And there's the presence of contamination within 2 kilometers of that population, which was found by a study, I think 20 odd years ago, to find out that most casualties happen within 2 kilometers of where people live. Then the green boxes are the things that we can do. We can clear an area at the bottom. We can also use mobile explosive ordnance disposal teams to get rid of contamination. We can give people effective risk education, and I stress the word effective. We can do NTS to find out the nature of what's going on. And actually, the other thing we can do is give alternative livelihoods to people, because if we give them something else to do, the economic pressure on them reduces, and therefore we get reduced casualty numbers. So mine action as a system looks like this. It doesn't start at the minefield fence. It's just taken us 30 years to realise it. Okay, so any questions so far?
Yes, we do. We have one coming in from Neil Thompson. Has there been many studies on mine migration in different soil types? So sand, clay, etc. The movement of mines over the years underground.
I believe there has. It's not something I've looked into a lot personally, but I remember there was an entire NTS being carried out by a Canadian organisation about 20 odd years ago in Mozambique that had to be cancelled because of a flood. And I know it gets mentioned in Cambodia quite often because of flood. But I would ask you to remember, most people to remember, and Neil, if you're the same Neil Thompson that I know, I think you still owe me $20, by the way. But the most people should understand is that if you've got a mine made from cast iron, it doesn't float. Now, what happens to that with the low erosion and stuff that's built on the side of slopes? Yes, it can migrate. There's no question of it. But I don't know that we've done that many studies of it. I'd be really interested to see them, and other people in the audience may well know. It's one of the reasons, Michelle, why I hate the word expert, because a expert implies in English that you know everything. And this is a subject I know a little about, but not much.
Thank you. I had a question. It's something that you just spoke about, effective risk education. Can you just very quickly go over what in your mind would be effective versus ineffective education?
Oh, I can talk for hours on this, but I won't. The key point is that in behavior change communication, an outcome is a change in behavior. And some of the problems with the risk education that I've seen over the years is it tends to be loads and loads of pictures of stuff. This is this mine, this is this mine, this is this mine, this is this mine. But what we need to be doing, as a very clever woman said to me about 30 years ago, by the time we recognize an individual mine, it's already too late. And at that point, Belinda Goslin, because that was the lady, she changed the whole face of risk education at that point with that one question. And she's not recognised often enough. But the point being is that we have to give people advice on what is unsafe behaviour, but also what is safe behaviour, and then we have to measure it. Whereas what we tend to do is just point at posters. And so that's what I mean by the difference between effective risk education and not. And you have to bear in mind there are 5 types of risk-taking behaviour, which is outside the scope of this presentation, but we have to make people be willing to modify their behaviour rather than just give them information.
Perfect. Thank you so much for that answer.
Okay. And let's move on then. So risk and liability. Right, well, let's just go back to the sort of technical nerdy stuff that some of us are really interested in. And we're going to talk about probability of detection and depth. And what tends to happen is our probability of detection increases as our depth gets slower. This is for all these various sensors that people use, whether it's a magnetometer, a mine detector, radar, ground penetrating radar, whatever these things are. We tend to find that this is what happens. So the deeper the stuff is, the less likely we are to find it. Similarly, the more we increase the sensitivity of our devices to make them find that deeper buried stuff, then the false alarm rate goes up, which can mean in some places we just end up putting our metal detectors down and just clearing the ground by hand because we get so many false alarms, it's just not worth using the metal detector. So let's keep on talking about detection a bit more. You see, the problem is for us, this is what in nuclear weapon, the nuclear weapon sphere, this is an always never problem. We always want you and your device to find targets, and we never want you to miss an item. So when you're used to things like, oh, we've got 95% confidence in our results or 99% confidence in our results, that's frankly not good enough for us. It's always or never. There's no point in it, but there's no point in approximate results. There's no point in you saying to me, oh, there's an area size of a football field over there. It's between 15 and 19 targets. What good's that to me? Now, we will accept some false alarms within limits, because otherwise we'll just have to put the detector down and forget about it. And you can think of this as a very extreme form of hypothesis testing to bring this back into the realm of science. And what I also want to talk about, of course, is the economics of this, because this is where I feel at home. We've got the expense, we've got effectiveness, more or less. What, of course, we want is more effective, less expensive. What we can't accept is less effective, more expensive. And the other two, there's a trade-off. An area where this comes up is on one of the problems we have with our survey techniques is the boundary setting errors. So we've got the presence of contamination, looking left to right, and we've got the action of our survey teams. So the contamination can be actually clear, or it can be actually present. We can declare the area as contaminated, or we can declare the area as clear. And again, this is those of you with a scientific or statistical background will recognize this as hypothesis testing, because we're quite happy if you correctly identify that contamination is present, and we're quite happy if you correctly identify an area as clear. What we are worried about is when you fail to identify an area as clear, or even worse, is when you fail to identify the presence of contamination, because this is an efficiency error, but this is a safety error. And one more thing to talk about then in terms of risk and liability is benchmarking. Some of you may recognize this, some of you won't, but this is a very common type of scatterable mine found in Ukraine at the moment. And you may well get some of these and you may say, right, we have to match our targets against reality. There's an example of something that somebody was using recently as a target for their equipment. But that letter there in the picture, that means this is an inert training mine. So therefore, the contents of it are not necessarily the same as the real mine, which means you may have trouble benchmarking yours. If you've used this as a benchmark, you don't know that your device is calibrated correctly. So, any questions so far before we go on to the final section?
Yes, we do have two questions. There's one from Frank that's a bit more personal. We can save that to the end for the discussion. But we've got one from Pedro again. Thanks again. He's saying, excellent session, always a joy to hear. Assuming you would have no constraints or on resources, if you would have to choose one specific problem to solve today, a problem worth solving, cheaper, faster, and not less safe than presently, which one would it be?
You're asking an economist. We only operate in conditions of scarce resources. So that's, frankly, that's a hypothetical question that I'm not going to go into. We always have scarce resources. If we didn't, we'd clear everything today.
Perfect. Yeah, so I see Tino has raised his hand. I don't see a question though. Francesco, do we want to turn the mic on, or I'm not sure.
Yeah, sure. We could see if they are here.
Yeah.
Tina, you have permission to talk if you would like to unmute.
If you have a question, maybe we can get to that at the end then. Or would you like to answer the other question, Dr. Keeley? More about your thoughts.
Which question?
So we've got one from Frank that says, how do you feel, given all your work experience, when you see conflicts like the one we see today in Ukraine, or how countries like Finland are now securing their borders with landmines, something we once considered banned, including new types of munitions, such as those deployed by drones? What are your thoughts on that?
Well, I could go on, to be honest, I could go on for hours about that. And so I'm going to swerve that question, to be honest, because I don't think it's, well, I think we need to stick to the subject. We've still got another section to go. But if he wants to contact me offline, I'd be delighted to talk about it.
Okay. We just got one more coming in from Jonathan Girthy. Benchmarking against explosives. When that is, what is to be detected? Is it is extremely difficult to achieve due to restrictions on use, storage, and handling of explosives in some countries.
Absolutely absolutely right. There are at least two people out there, though, that I know who make analog targets that are suitable for testing as benchmarking. They're not cheap because somebody who makes a landmine makes them in their millions, and their cost is a few dollars. Somebody who's making an analog is making a dozen at a time. So the analog targets are expensive. There's no question of it, which is an issue. But if you don't benchmark them, you've got no idea if they work or not.
Okay, yeah,
But
we'll let you.
there are people out there that make the suitable targets.
Okay, perfect. Yeah, feel free to jump into your last section, and then we'll get to the other
Okay.
questions.
So at the moment, I've given you some background and I've talked about some of the problems. So let's talk about some ideas for going forwards for the innovators. Right, just something to bear in mind, and this ties in with the benchmarking. We have our piece of equipment that you've designed, and it's going to get used, and it's in the laboratory, and you find that in your laboratory or on your field, it's safe, it's effective. But when it's used in the field, we've got to take into account both environmental factors and human factors. And so sometimes we find a piece of equipment that worked well on your workbench doesn't work in the field. You must bear that in mind. So here is what I have used in the past as a 4-step protocol for this type of work. And when I have been able to use this, I found it works. So demining 101, this is the first stage. This is about watching, listening, asking, learning. It's about you learning in the sector. Now, we've had a bit of a burst today. We've taken nearly an hour to talk about this, but there's a lot more to talk about. I'm going very quickly, and there's a lot more to discuss. This is a 3-day session if we did it properly, and it would mean looking at work being done in the field. So again, if any of you would like to talk to me about that offline, about how to do this, very happy to do so. The next stage, armed with that knowledge, like Warwick University did all those years ago, we've got the breadboard session. This is when you now try your prototypes against FFE or surrogates. Now, this isn't a pass-fail test. This is about you practicing, getting the idea of how it works against a target that is effective, that's an accurate target. But this you can take as long as you like over this, and you can do it wherever you like, frankly. This has to be followed up by blind testing, and this is testing against known and benchmark targets. And at this stage, this is done to get statistical significance. But if some of you will recognize this system as we're going through it, because this is the same mechanism that the CDC uses to test new drugs. That's where I got it from. And if it's good enough for the CDC to test new drugs, it's probably pointing us in the right direction. So blind testing, I know where the targets are, you don't. And then you tell us where you think they are, we'll tell you where they were, and we can get statistical, if we do it enough times, we'll get statistical significance about the performance of your equipment. But at this stage, nothing has gone into a real minefield yet. And you might notice that as we're going through this, the cost of this is beginning to increase. And the final stage in this is testing a double-blind test. And the way we have to do that is where I don't know where the targets are either. So we have to test against a real area. The results that you find with your equipment have to be compared to the results with the control. And the control in this example is manual deminers doing it in the traditional way. So you've found 97 devices, they've found 98, you've missed one. Or you found 98, they only found 97. That could happen, theoretically. So that's what a double-blind test looks like in real life. So when I've done this in the past, it works as a system. Now, bear in mind, what this also does is it you can think of those yellow arrows on there as NASA's go, no go windows, in the sense that at any point you can stop spending money on this. So as you go down the system, if you decide that your device isn't going to be any good and it's not gonna work, you can stop at that point and save yourself spending any more money. Now, what if that's not a detector you want to test? Well, it's the same four-step layout, but we would design test against intended results. Remember, faster, cheaper, or safer, where you can point to somewhere in the area in the mine action system that you intend to have a result. So, for example, a brush cutter, it's not intended per se to clear mines, but we would look at things like the density of the vegetation and the rate of clearance that it would achieve. But remember, at each stage, what we also know to bear in mind is cost effectiveness, because we have a solution, and that's that man or woman that we've already trained and successfully employed as a manual deminer. You have to not only be faster and safer than what he or she can do, but also cheaper, because they take their money and they put their kids through school with it. Please bear that in mind. So we need to measure the benefits compared to the current way we're doing things. Right, some final thoughts. Mine action is a system. Area clearance is only one of several activities, and it's actually, in many respects, the simplest thing we do. Detection is only one of the final elements, and the earlier in the process that you can intercede, the more value we add. So please learn the system first. It will save you time and money. We're just going to finish here with a, if you like, an executive summary, or as my American friends call it, an OV1. Our contents, we've talked about these 5 things: the pillars, faster, cheaper, safer, the system, the risk and the liability, and the test protocols. With a headline I'd like you to take, to think about is that we fail when we fail to situate or when we fail to demonstrate. We have some metrics: faster, cheaper, safer, and benchmarking. And the key takeaways: mine action is a system. Area clearance is one of several activities. Detection is the final element. The earlier in the system you can intercede, the more value you add. And finally, learn the system first and save money. At that point, I'll take any other questions.
Thank you so much. I think I'm gonna remember faster, cheaper, safer for the rest of my time here. Yeah, thank you for the presentation. I would like to invite now Shahab Moini and Pedro, our previous speakers. If you guys want to unmute yourself, feel free to jump in. The Q&A box is still open if anyone has any questions for our speaker today.
Yeah, I just want to thank both. Thank you very much for this explanation. I'm talking about the fundamental of the mining, especially when it comes to the new technologies. That many they
Okay. A question that we have in from Henry is, why don't developers already do testing in this way?
Well, it's interesting because some of the abject failures we see are involving something called the sunk cost fallacy, which is because people don't tend to do as often as they should do. What Warwick University did is they get an idea, they don't come and look, they don't situate. As I said, they don't situate, and then they go off and spend quite large amounts of their own time and money, sometimes their own personal money, developing a piece of gear which doesn't fit. And then they come to a meeting or conference, they present it, and they go, "Da-da! Look at this! I've solved your problem." And then they get shot down by various people in the audience. And the problem is that they're worried that the cost of the testing and evaluation is too much. It's too much of a cost. And actually, what I would say is not doing it is potentially much more expensive.
Perfect. We have one last question, and then I think we'll have to wrap this up. But from David, when a flail is used, must it be followed up by a manual check?
Yes, in almost every national standard I know, and also for reasons I've said. The problem with this a flail, like a lot of these devices, is the tool is essentially a cylinder. As the flail chains rotate and the hammers rotate, it's a cylinder, and you can set the cylinder at a certain height or depth on the ground, but anything that's deeper than that cylinder passes through is missed. There's also a problem if there's a rock or an undulation or a fence post or some obstacle on the ground. If there's a weapon or a mine near that undulation or that rock, it misses it. Um, if there's operator error, missing bits in the gaps. And if you look into the history of some of the earliest flails, for example, on the invasion of Normandy, there's quite a lot of reports of flail A being blown up on a mine, flail B being blown up on a mine, and then flail C finally making their way through the minefield, which implies that those first two machines were struck a mine under the track of the vehicle, not under the flail itself. So they're not 100% effective, and they are good in the sense of as a vegetation clearance device, as a ground preparation device, but they are not 100% effective.
Perfect. Thank you. I think we have about 2 minutes left, 1 minute left. I just wanted to say thank you, Dr. Keeley, for this very insightful presentation. Faster, cheaper, safer is going to be on the top of our mind for the rest of the day. But thank you so much for all your questions to everyone that's joined us here today. Thank you for our panelists for also jumping in. Francesca, if you want to do closing remarks.
If I can just one last thing on my point of view, if anybody out there, any innovator would like to talk through this in more detail, I'm very happy to discuss some of these ideas.
You do have lots of questions coming in for your thoughts, so I'm sure you'll get lots of emails.
I'm sharing my email here. If anybody would like to connect with Dr. Keeley offline, I know I will already be connecting you with Quentin and with Frank, who have both already reached out to me. So I'll send those introductory emails after the session. But for anyone else who would like to follow up with Dr. Keeley after the session, please send me an email to the address that I just put in the chat, and I will make that introduction. And yeah, just to wrap up, thank you so much, Dr. Keeley, for that great presentation. Thank you, of course, to Michelle and Shahab for all of your work in putting the series together with us, and for all of the support as the series has progressed. And thank you, of course, to Pedro as well for joining us again today. And thank you to everyone in the audience for taking the time to join us. I hope that these sessions have been interesting and informative. And we look forward to seeing you all again next time. So just as a reminder, this is a monthly series. So our next session will be in June. And all of these sessions are recorded. So if you do want to go back and revisit any of the sessions that we've done so far in the series, you can find that on our YouTube channel or on our event page. And I've shared all of our social medias, including our YouTube, in the chat as well. So please go and find that there. And just as one last thing, if you do know anybody who's interested in this kind of series or in these topics but hasn't registered yet, please do feel free to share all that we're doing within your networks. Our registration is always open and free until the end of the series. And the series is going on until the end of the year in December. So there's still a lot of time to catch some really good sessions. So please do continue to share it within your networks. So with that, just one last big thank you to everybody for being here today. It's a great session. And we look forward to next time. So cheers. Thank you so much.
Thank you so much, everyone.
Thank you very much.